Right, this is Maths Linear Algebra Tutorial 8, question 1, part 7. In this question, we're given a matrix A, 3 by 3 matrix, and we are given lambda equals to 4 is an eigenvalue of this matrix, and we are supposed to find the corresponding eigenvector. So let's practice again. Remember that once we are given lambda, we can use this expression AX equals to lambda X. To solve for eigenvector x, we need to ensure that x is not the zero vector. The given lambda is 4, so we put the expression in this form. We move the whole thing onto the left hand side. Ax minus 4x equals to 0. We use the trick of minus 4i x equals to 0, and now we note that we want to make sure that the determinant of this matrix is equals to 0, implying that this matrix is singular, or implying that this matrix has dependent column. When it has dependent column, it will have this case that A minus 4i times a non-zero x such that the zero vector will arise. So this is the reason. We've done this before, and now we will proceed from this equation, which is called the characteristic equation, and we will now solve. First, we write down what is A matrix, and now we have 4i, which is 4, 4, 4 in the diagonal, and we will get A minus 4i to be this matrix. Once we have this matrix, we can solve for the eigenvector. What we do is to use Gaussian elimination to get the row reduced echelon form of this matrix. Once we have the row reduced echelon form, we can generate the parametric equation for the vector x. We will write the augmented matrix, which is the matrix A minus 4i, with the right hand side to be all 0 to solve for the homogeneous equation. I will not do the row reduced echelon computation. I'll just write the solution for you. When the matrix is reduced into this form, the reduced row echelon form, we can write the equations of relating x1 with the free variable x3. So let us first identify the pivots, which is x1 and x2 location, showing that x3 is the free variable. So we have x1 plus x3 is equals to 0 from the first equation, and from the second equation is minus x2 minus x3 is equals to 0. This implies that x2 is equals to x3, and this implies that x1 is equals to minus x3. We now can write the parametric equation x1, x2, x3 is equals to x3 with this coefficient minus 1, 1, and 1. I made a small mistake here. Should be x2 is equals to minus x3. So this is the correct eigenvector. For sanity check, we'll have A multiplied by minus 1, 1, and the result is we'll get minus 4, 4, showing that if this is the eigenvector x, we have 4x. Therefore, 4 is the eigenvalue, and x, this form, is the corresponding eigenvector. Thank you.